Morning, everyone. My name is Álvaro Sánchez, and I promise you two things. You will learn something new, and you will have fun. So let's begin. I'm coming from Madrid, Leganés. Any Español or Las Palmas fan here? No? I'm a Java developer. I've been always working on Java. I've used other languages like JavaScript, but only because I was forced to. I'm working at Oracle on Micronaut in different areas. The part of Oracle that I'm working for is Oracle Labs. It's a research and development organization within Oracle, and it's coming from Sun Research. It is the home of a project that you may have heard of, which is GraalVM. So GraalVM is kind of a sister project. I'm not a developer advocate myself, but I enjoy going to conferences like this to speak about Micronaut Java or anything else. And I'm really proud that I've been able to do this without doing any single talk about AI, which is, believe me, it's getting more and more difficult to get talk accepted at the conference if it's not about AI. Cool. At a personal level, let me tell you that I'm a runner. Yes, I run a lot. Don't be surprised. Look at me. I'm a runner. I run a lot, and I run very fast. I run containers applications. And okay, anyone has been at a previous presentation by me before? Okay, so I can still make the same jokes over and over. I'm telling you that I've been working on Micronaut since the beginning. Micronaut was, let me tell you a small story. So Micronaut wasn't called Micronaut at the beginning. The code name was Particle. But Particle was, there was like a trademark or the main name was not available, blah, blah, blah. So we had to choose a new name. So we ran a poll internally across the team to choose a new name, and my proposal was to name the framework Summer, because we all know that summer is better than spring. It's a joke. I'm literally a former VMware employee, so nothing bad to say about them. So that's enough about me. Let me ask a few questions about you. So I guess all of you are Java developers. So who's using Spring Boot? Please raise your hands. Okay, exit over there, thank you. Anyone using Quarkus? Anyone using Micronaut? Yeah, you're at the right place to learn about it. But this talk is not about Micronaut. All right, slides available on speaker deck if you want to take a picture. Not only this one, but others. Meanwhile, Horacio, what time is when I should be supposed to be finishing? 45. Okay. Okay. Thank you. Let's begin. So, annotation processing. Everyone is using annotations. But do you really know how they work? So that's why we are here for. Annotation processing in Java normally is a two-stages process. We, first of all, need to discover them, right? There has to be some mechanism to find the annotations on your classes. So think, for example, about, I don't know, at-rest controller, right? And once we found them, there's some logic to implement with it. Like, for example, if it's at-rest controller or, for example, at service, we need to create an instance of that class and register it into the application context. If the annotations is transactional, we need to generate some code to basically wrap that method into, transaction boundary. So let's talk about, first of all, runtime annotation processing. So we can do this at either runtime or build time. Let's talk about runtime, because runtime is the most common approach based on the number of hands that people raised about Spring. So let's talk about Spring. In Spring Boot, when you have a Spring application, Spring will iterate over your classes of a given package, right? That's the default. They will use a custom class loader, and they will use a reflection API to, they will first load every single class into this custom class loader, and will use reflection API to query about the annotations for all those types. And once they have the annotations for the types, they will do the same for fields and methods. Every single class, every single field, every single method. Throughout this session, I've included little exclamation or warning icons to highlight things that I think, in my opinion, are not so well done, or could be done differently. Let me be polite. So why using a custom class loader is not a good decision? Because this is happening at runtime. Every single time you start your application, this will happen. And there is no limit on the number of time that it will take for a Spring application to start. Because the more classes you have on your class path, right? And this is not only happening for classes in your project, but also for dependencies, right? They will, for example, process auto-configuration bins on the class path, right? Using a custom class loader, loading the classes, every single one, when your application is starting, is going to be expensive. Using the reflection API is slow. I will talk about reflection usage later. There is a new Spring AOT module. Anyone is using Spring AOT? Okay, yeah. I think I'm not following closely the Spring community, but I think this is the intended direction that you should be looking for. So Spring AOT is a new module where they, instead of doing all of this at runtime, they try to do some of these things at build time, right? To reduce the amount of operations that are on startup. There are more options in the Java ecosystem, like, for example, class graph. Class graph is a library that is used by some tools, like, for example, OpenRewrite is using class graph internally. If I were to create my own framework today, it's probably what I would choose. But I don't recommend you to create your own framework. Class graph instead is, again, at runtime, but it's swallowing the binary format directly. So it's parsing the bytecode, right? This will save the amount that it takes to load a class into a class loader, because loading a class is an expensive operation. And you need to take into account that, for example, loading a class will also trigger static initialization blocks, which may have, I don't know, method call that will be executed. So if we are only interested in the annotations, class graph will parse them, will parse the class files without loading them. Considering that this is at runtime is kind of efficient, has some advanced capabilities, and is highly optimized, right? And once you have done this at runtime, they will give you methods to query about, like, for example, give me all classes that implement service or something like that. There is another library in the Java ecosystem, which is Burning Wave Core, and it's an alternative approach, but it works kind of the same, right? Those are the two options that you have to process and to find annotations at runtime. You either use class path scanning at runtime, or use an alternative library that will parse the class files directly. Now, once we found the annotations, how do we implement the logic? There is a built-in option called dynamic proxies. Dynamic proxies is a built-in capability of the JDK, and it allows you to generate new classes for interfaces, right? It generates bytecode at runtime, and then it will load the new class into the class loader. So if you think about, for example, a repository interface, and you have this Spring Data repository annotation, theoretically it could be implemented with dynamic proxy. There is a setting in Spring Boot where you can actually force Spring Boot to only use dynamic proxies. But then if you try to use an annotation on a non-interface, like for example, a regular class, it will throw an exception and will tell you that you need to disable this setting. So this is a limitation of dynamic proxies, but this has been in Java like forever. Since this is not enough, there is a library which is also quite mature called cglib. cglib is what Spring is historically using to generate proxies and basically proxies for any class or interface. So if you think about the Spring, dependency injection, your classes are typically not instance of your classes, right? But they will be something else. And if you have debugged a Spring application, you will have realized about that. So the stack trace is gigantic. cglib will also allow you to mutate existing classes. According to the cglib project itself, it doesn't work well, or possibly at all, in newer JDKs. And this was a statement a few years ago. So the thing is that the Spring is using its own fork, right? So it's not using cglib open source directly. They fork it. They keep an internal implementation. And for the use case of Spring is probably enough. cglib, and as many other alternatives, is using ASM. ASM is the foundation, or has been the foundation until now, for low-level bytecode manipulation. ASM is very low-level, so you are working with the bytecode instruction set. So you need to be familiar with, I don't know, load instruction, read instruction, etc. There is another alternative to implement this annotation logic at runtime, which is ByteBuddy. ByteBuddy is a much more modern library. It's used by Hibernate, Mockito, Jackson, Selenium, Spock. Like any recent library will use ByteBuddy if they rely on runtime annotation processing. It has 3 modes of operation. They have like a Java API, which is what I will use to generate, for example, a proxy. There is a Java agent that you can attach to your build, or build plugins for Maven and Gradle. It is fast, but again, this is happening at runtime, and has a nice API, examples, etc. And finally, there is a new Java standard called the class file API, which is already final release. It's an internal replacement for ASM because guess what? The JDK itself internally was using ASM as well. Like for example, when you have a lambda, this lambda will be generated into an anonymous linear class dynamically at runtime by the JDK, and they use ASM for that. But the ASM quote in the Java architects is an old code base with plenty of legacy baggage, and it also introduced this problem of since it was used by the JDK project itself, they couldn't. They have this chicken and egg problem. So if they were working on a newer language version, they didn't have any ASM version supporting this future Java language version. So they had to do some tricks to make this work, but not anymore. So this is supposed to be a new standard, and the API is similar to the one of ASM. Let me show you one example very quickly. Is dark mode good enough? Yeah. So in this case, I'm going to use ByteBuddy. So let me show you very quickly what we have here. I want to implement a timed annotation. This guy here has a runtime retention policy, which means that when this is compiled, and I use reflection API to query about the annotations of any type that is annotated with this, I will be able to see it. It could be, there are other retention policies like source retention, for example, right? So this guy here is used in a method, and it's supposed to be what you're guessing, so to measure the time that a particular method is taking. So this is a service. The implementation of the method is simply introducing a random weight so that we get different numbers when we run this. I'm using this singleton annotation as a marker interface to find those classes. So the actual main method, which if we run it should work, if the demo codes are with me. Uh, 93 milliseconds, and now we got something else. Tooltip go away. Yeah, 1.5 seconds. If we run this in the back mode, this my time service is not my time service instance. It's a proxy generated at runtime. If I were to look, the class here in the target folder is not there. Okay? So far, so good. Blink your eyes if everything is going well. All right. What's the problem with this? What's the problem with runtime processing? Class path scanning is slow. It's a file I/O operation to read elements. That could be like, for example, if you're running your application in development mode, reading your classes is going to be kind of okay because they are like expanded. But if I need to read classes from a jar file in the file system, that's gonna get complicated. And let me say it again. This is happening every single time you run your application. And you will say in production, I run it once and I forget. Sure, but locally or for testing, right? Second thing is reflection API is slow. It is getting faster with every Java release, but this is still an expensive operation. So what happens is frameworks will use a reflective cache. So you don't have to query over and over again, which are the annotations of a class, right? You read from a cache. Because guess what? You're likely not only using only Spring, but also Hibernate. So who's using Hibernate here? Come on, raise your hands. Hibernate, yeah. So Hibernate is heavily based on reflection as well. And Hibernate has its own reflective cache. So memory consumption will skyrocket. The more classes you have, the more dependencies you have, the more time and the more memory consumption without limit. And also think about this. Every single time I'm running my application, we need to generate proxies again and again and again, right? Generating bytecode at runtime and then loading this class into the class loader is also an expensive operation. And also, runtime processing is going to be complicated with GraalVM. Although Frankos will sort it out for you. You don't have to worry about that. This has never been a problem when there was only one alternative, since there was only Spring. So why do we care about this? It's the only thing that we have. So let's use it. But there are other approaches, there are other techniques that we can, there are other magic tricks that we can use. Now we are moving to the compile phase, or let's talk about more generally the build phase, right? There are other libraries in the Java ecosystem or other techniques that can be used for annotation processing. Talking about annotation discovery, so how to find the annotations. We have Yandex. Yandex is the library used by Quarkus. Quarkus is using this library. What Yandex will use is during the build, it will process your classes, right? During the build. Which is different to the compilation phase, which I will explain later. It will parse the bytecode and collect all the metadata about classes and annotations and hierarchies into a persistent index. And this index is going to be loaded by your Quarkus application when you run it, so that they can query annotations. They can do queries like give me all the I don't know, all the controllers or all the REST resources, for example, without using reflection. Right? Once they found these annotations, they will use Gizmo. Gizmo is the internal library used by Quarkus to generate new bytecode. Right? It's written on top of ASM and can also manipulate existing classes. Right? Quarkus has two different ways of bytecode generation. Gizmo is the internal one, although it's a library that you can use in your Quarkus applications. If you are creating your own extension, you could use Gizmo to generate new classes with a Java API. Or for the most simple cases, they have this byte recording approach where you basically have your the code you want to generate in a recorder class, and that bytecode will get compiled, and they will inject it in the places that needs to be injected. But there has been an option called Pluggable Annotation Processing API since Java 6. It's probably someone here who wasn't born yet. 2006, right? It's called the Annotation Processing API. An annotation processor is a compiler hook. It's something invoked by Java-C. And it is the magic trick used by Micronaut or other libraries like Lombok or MapStruct. Is anyone using Lombok here? Raise your hands. The exit is over there as well. I have one slide for Lombok, so don't get me started yet. So let me tell you about annotation processing. If you remember what I said before, build time is not the same as compile time. Build time is like the whole Maven build, right? There are many things that could happen. But compile time is, among all the things that can happen during build, is the compilation phase, right? Java, let me do a small parenthesis and talk to you about Java compilation, which is a very amazing mechanism. Java compilation is done in several rounds, right? Or actually, annotation processing is done in several rounds. Because, for example, you can have an annotation processor to generate a class, to generate a source file, which has annotations that need to be further processed, right? So there will be a second round of annotation processing. During annotation processing, you only have sources available. There's no, you don't have access to any compiled classes or dependencies. And the annotation processor class path is different to the compilation class path, so should be kept minimal. Like, for example, if you're using Jackson in your application, that doesn't mean that you have Jackson available during annotation processing, and actually you should avoid it. Examples of what annotation processor can do during compilation. For example, you can generate source code, which is what the map-extract or Micronaut are doing. Anyone using map-extract? Yeah, popular library as well. During annotation processing, you can generate new bytecode, which is the approach taken by Micronaut. You can modify, mutate, manipulate, tamper existing classes, which is what our friend Lombok is doing. Or generate something else, like, for example, Micronaut will generate from your controllers, it can generate an OpenAPI spec file. Decorate is a separate library that, with few annotations, will generate Kubernetes descriptors, etc. So here we are, our friendly Lombok, our happy pepper. And yeah, Java compilation is done in 3 stages. In the first stage, which is parse and enter, is basically a syntax checking, right? It's a syntax checking, so if you have a syntax error, it will be detected in this phase. And after that, what the Java compiler will do is create the AST of your classes. An AST is a true representation of your code. So you have to think about, for example, a compilation unit, which is composed of blocks. Block could be a method or a field or an expression. You follow me, right? So this AST is passed to the annotation processor, which is the second stage. And this annotation processing stage could be, like I said before, could be generating classes with annotations that need to be further processed. So Java-C will invoke further rounds of annotation processing until there's no unclaimed source file and no annotation processor is pending. And finally, in the final stage, is like, for example, when the bytecode is generated, so it is going to be persisted to a class file. It is also a stage where the Java compiler will do some optimizations, like, for example, inlining or type erasure, etc. As you can see, there's no way for you to modify classes with annotation processing API. But in Lombok, you have, for example, a toString. And a toString, you put it on your class, and your class now magically has a toString method, right? So how the hell is this working? So Lombok is hijacking the AST, using loopholes in the Java compiler. And it's different loopholes in different compiler implementations. So there is one backdoor they found for Hotspot, another one for OpenJ9. They need to do this for every single compiler on the market to be supported. They will hijack the AST, injecting this bloody toString method in there, so that when the ASTs reach the analyze phase, it's going to be persisted in the classes, right? This is not a good idea, my friends. This is not a good idea. There are many functional problems. If you search on the internet about Lombok problems, you will find about functional problems. Like, for example, if I use @data and I'm using JPA, it will persist the whole thing into the database. I will have a lot of columns that I may not need. So I'm not going to be talking about you about these potential functional problems, but about the technical problems that is going to introduce, right? Using loopholes to implement something is not a good idea, because basically for every new Java release, right, in September 15, there will be Java 25, and on that day, if you are using Lombok, you're not going to be able to upgrade, because they need some time, because these loopholes are going to be closed. right? There is an official Java enhancement proposal, which is strongly encapsulate JDK internals, which I refer to as kill Lombok. So they have to find other ways, right, to do this trick. This limits your ability to upgrade to newer Java versions. Mutating the AST breaks other annotation processes, like, for example, if you use Lombok with Micronaut, and Lombok is run last, it will destroy what Micronaut generated, so Lombok needs to run first. This AST manipulation breaks incremental compilation, which is a feature you're only going to enjoy if you use Gradle. And do we need it today? I mean, with Java 8, I get the point. But Java 24 is not Java 8, my friends. So now we have much more modern building blocks in the language. And there are many things that we probably don't need. That's a food for thought for you. So how do we do it at Micronaut? Who's never heard about Micronaut before? Okay, small parenthesis about it. Micronaut is a modern open source Java framework created in 2017. Thinking of the type of applications that we create today. It is a general purpose framework. You can use it for any type of applications. People typically use it for REST APIs, but you can have, for example, a serverless function and deploy it on AWS Lambda. You can create a command line application. You can create a Kafka consumer or producer without HTTP server whatsoever. And the third idea about Micronaut is the performance. And by performance is not, I'm not only talking about peak throughput, which is also competitive, so there are benchmarks out there that you can check. But I'm thinking about two particular metrics that we are obsessed with, which are startup time and memory consumption. Because we believe that the startup time and memory consumption will dramatically improve your developer experience, which is the selling point of the framework. How do we do that? So Micronaut is essentially an annotation processing framework. Is using the annotation processing that I explained to you. So during build time, during compilation time, we generate all the framework infrastructure so that at runtime, there's no reflection, no proxy generation, no dynamic class loading, and we don't scan your class path. Most of the times we generate bytecode, but there are some cases where we are going to be generating source code, basically by popular demand. It's a smart compiler. Remember, annotation processing is compiler hooks. We support multiple languages. And we have many things, batteries included. In red, I'm highlighting things that you don't need anymore. Like, for example, we have Beam introspection, which is a replacement for the JDK introspector. We have Beam validation API, which is a replacement for Hibernate validator. Beam mappers as an alternative to Mapstruct. Micronaut serialization as a replacement for Jackson data vein. Micronaut data JDBC as a replacement for Hibernate. And SourceGen, for example, which is a replacement for most of the Lombok annotations, etc. Right? So our goal is to basically, if there is a single advice that I dare to give you today, is to reduce the number of dependencies, right? You will live much happier. So small implementation. The same timed annotation, but using Micronaut. So in this case, I have somewhere here. This guy, my time service is the same, but this is using a different timed annotation. This guy has a source retention policy, right? We don't need it at runtime. This is the case for most of the Micronaut annotations. And this is, by the way, going to reduce the class size, right? So your jar files will be a bit smaller. And well, the service implementation is literally the same with a random weight. And the main method in this case, we are running the main Micronaut application and getting the service from the application context, invoking the methods, and then finishing. Right? So this is going to work. And if we run it in debug mode, service is again a proxy, right? You see that? But this proxy is here. It's here, right? It's a class generated during compilation. So far, so good? Yeah. There is a new module that we're working on called source gen. The idea with source gens is to generate sources for more and more things. The core of Micronaut typically generates bytecode. Generating bytecode has the biggest advantage of generating something which is already compiled. If we were to generate sources, sources will have to be compiled. So we decided to generate bytecode to save compilation rounds. But then users started to claim like, okay, we want to see the sources for this because if I want to debug it, etc. You need to be aware that the stack tracing Micronaut is 10% of that of Spring because there's no intermediate layers, right? So, for example, with the case of transactional, we generate a proxy class which is sitting next to your class, and there's nothing in the middle, right? There's no dynamic proxy generated on the flight, etc. You will not see like 10 frames in the stack coming from the CGLib. But still, we said, okay, so let's generate sources. And we are shipping few annotations that are a replacement for that of Lombok. But there's, for example, the case of toString. In the toString, we don't change your class, right? Like, for example, if you use toString in a person record, we generate a person utils class with the toString implementation. It's a trade-off. I mean, ideally, we get that you will want to have this toString in your class, but it's a crime to basically touch your bytecode. So why startup time and memory consumption matters? Because you would say, like, I run my service in production and I forget about it. First of all is developer productivity, like I said. So you can run functional tests in milliseconds. And by functional or end-to-end tests, I mean running, like, for example, you're probably used to using something like Spring MVC, MonkeyTalk, etc. This is all libraries that have been getting popular because of the problems of a Spring of running our application. It's prohibitive to run your Spring applications all the time to run functional tests. But ideally, what you really want to do is to run an integration test where you run your entire application, you grab a bean from the application context, and you do a method call. And if that can happen in milliseconds instead of seconds, then it's much better, right? The second answer to this is cloud native. If you have applications that can come up instantly or quite instantly, we're talking about, for example, Hello World in Micronaut in JIT mode is 250 milliseconds in modern hardware. If we compile to a native image, we're talking about 8 milliseconds, right? If it's going to be like a more realistic application, not a hello world, we could be talking about, I don't know, 50 milliseconds in native images, 100 at most, right? So if you had pods that can come up instantly, you can scale to 0 or almost to 0. Because if load is coming, you can scale up very quickly. And also serverless. In serverless, the less amount of time your function is going to take, the less money you pay. So it's going to literally save you money. And there is a nice use case of Disney Plus. Disney Plus is a pure serverless shop. They're using AWS Lambda a lot. And they realized that using Micronaut and GraalVM would be a huge cost saving. For questions, I don't know if we have time for questions, Horacio, and 5 minutes, excellent. So in the meantime, well, there is this Codemotion app feedback rating, but I have my own in case. If you want to reach out to me, I have links to my social media if you want to rate me. And yes, there any question?
There is another question in the application. Is Micronaut going to be adopted by the JDK, or there is a strong recommendation from Oracle to use it?
No, so Micronaut is an Apache 2 open source framework, so that's all about it. It has no connection whatsoever with the JDK. The Oracle group working on the JDK is a different organization across Oracle. And Oracle is just sponsoring the developer time to implement it. Why? Because Oracle is #1 user of Micronaut in the world. We have dozens and dozens of teams. It's literally powering Oracle Cloud. So Oracle Cloud is powered by Micronaut and GraalVM, but it's also being used by other Oracle organizations like NetSuite, etc. So obviously Oracle has an interest in maintaining Micronaut.
And there is another, I think it is the last one. What about Aspect-J?
Aspect-J is AOP library. Is not supported by Micronaut because it heavily needs reflection, so we don't support it. But we have a Micronaut AOP framework. In the demo, I showed, let me show it very quickly. So this guy here, my time service, I didn't show, sorry about that. I didn't show the actual implementation of the interceptor, right? So this is an interceptor bin of this annotation. This is an AOP framework that we have, but this is compile time. It's not runtime. Okay, so I think time up. So thank you very much for your assistance.